This video presentation is brought to you by the Pro Mathematics Academy. Welcome back to another video presentation brought to you in part by the Pro Mathematics Academy. In this video, we'll be looking at some practice questions for our calculus mid-semester examination number 2, right? And we begin by kicking off things with a limit question, of course, right? So here we're looking at the limit as x approaches 0 of tan x divided by cosine x, right? And if we recall, right, the limit as x approaches a of f of x over g of x is equal to the limit as x approaches a of f of x over the limit as x approaches a of g of x, of course. And this rule is what I will apply here. Note, this is particularly useful when the limit as x approaches a of g of x is not equal to 0. So in this case, we have tan of x over cosine of x, and we know that as x approaches 0 of cosine of x, right, cosine of x tends to 1. Okay, so in this case, we can simply evaluate our limit as x approaches 0 of tan x over cosine of x as tan of 0 divided by cosine of 0, which is equal to 0 divided by 1, which is equal to 0. Okay, simple and straightforward. All right, any questions? Not really. There's no one here. So we move on to question number 2, right? Here we have sine 2x over 1 plus x times the log of 1 plus x. Note, here log of x is equal to the natural log of x, okay? This is something we need to keep in mind as we go through this examination, right? So what am I going to do here? Right? I'm going to say let's apply L'Hopital's rule. Okay, how do we know when to apply L'Hopital's rule? Simply, any situation where we end up with 0 divided by 0, right, which is the indeterminate form, right? And what does it mean to be indeterminate? It means we have small over small, okay? So this is not really 0, guys. I'm just using 0 here to represent small. And here in the denominator, I'm also using 0 to represent small. So if we have small over small or large over large, then this is the necessary criterion that we need to satisfy before we can apply L'Hopital's rule, okay? All right, so let's also put this to the side. And not to give too much theory here, guys, but we're going to apply L'Hopital's rule in this situation. We differentiate our numerator, which is sine 2x. So if we differentiate sine 2x, we end up with 2 cosine of 2x, right? And in our denominator, we'll differentiate 1 plus x times the log of 1 plus x, which is the product rule, right? Which says that we have to take the first times the derivative of the second plus the second times the derivative of the first. Okay, so now we can take the limit, right? So we can say that the limit as x approaches 0 of sine 2x over 1 plus x times the log of 1 plus x is the same as the limit as x approaches 0 of 2 times cosine of 2x over 1 plus log of 1 plus x. Okay, so here, since our function is now continuous, we can insert 0. So this becomes 2 times the cosine of 0 divided by 1 plus the log of 1, which is equal to 2. Okay, and note that there is another way we could have worked this question. Okay, so keep that in mind. Scrolling. Question number 3. Now this one is a question that oftentimes challenges students. All right, But here I'm going to work it using two methods, right? So method one, I'm going to apply L'Hopital's rule again. Okay, so in this case, I differentiate my numerator. This gives me p prime x plus 3h times 3 because I'm differentiating with respect to h. Okay, so that's what is very important here, guys. I'm differentiating with respect to h plus p prime x minus 3h times negative 3. Okay, minus 0 because when I differentiate 2px, this doesn't have a h component, so it becomes 0. And I'm dividing by 2h because I differentiated my denominator here, which is h squared. And if I differentiate h squared with respect to h, I end up with 2h, right? I still have to differentiate one more time. Okay, guys? So you can't differentiate once for this example because it will still be in an indeterminate form. All right? So let's go. So differentiating my numerator, again, I end up with p prime prime x plus 3h, and I'm applying the chain rule here, guys, right? Times 9, okay, plus p prime prime x minus 3h times positive 9 because negative 3 times negative 3 gives you positive 9. Okay, and I'm dividing all of this by 2. Now that I've differentiated both denominator and numerator twice, right, I can now say that the limit as h approaches 0 of p of x plus 3h minus p of x minus 3h, is that a minus? Nope, it's a plus, minus 2px, right, divided by h squared is the same as the limit as h approaches 0 of, I'm just going to copy down my expression here. I guess I can't copy. p prime prime x plus 3h, well, times 9 plus 9 times p prime prime x minus 3h, all divided by 2. And now, since the form is no longer indeterminate, right, I can plug in h equals 0. So this gives me p prime prime x times 9 plus 9 times p prime prime x as well, divided by 2, which is equal to 18 p prime prime x over 2, which is equal to 9 p prime prime x. Okay, wow, that's pretty neat. Okay, so I have limited space to apply my second method. So method number 2, because persons are going to say that they're not comfortable with that approach. So here, notice that I didn't even read the question for you before. So it says p of x is a polynomial function and x is a real number. What is the value of this limit? All right, so p of x is a polynomial function. So I'll say, okay, method number 2, I know many polynomial functions, but my favorite is x squared, which is the quadratic. Okay, so p of x here is equal to x squared, right? And I know that p prime of x is equal to 2x, right? P prime prime of x is equal to 2. Nice. So now I'm going to go and I'm going to try and figure out this limit. So the limit as h approaches 0 of p of x plus 3h, right, plus p of x minus 3h minus 2px, all divided by h squared, is the same as the limit as h approaches 0 of x plus 3h all squared plus x minus 3h all squared minus 2x squared, all divided by h squared. So I'm looking for some scalar times this. I'm looking for some scalar of 2. All right, that's what I'm looking for as the answer, which will make sense when I get to the answer. So here this becomes x squared plus 6xh plus 9h squared plus x squared minus 6xh plus 9h squared minus 2x squared, all divided by h squared, which is equal to, let's see, which simplifies down to 18h squared over h squared. Okay, and if I look at this closely, I realize my final answer is 18. The question I now ask myself is, 18 is a multiple of 2. So that means my 18 that I'm looking at is really 9 times 2, which is equal to 9 times p prime prime of my polynomial that I chose. Okay? Nice. So we have two methods here. Please go with the method that you're more comfortable with. Here we're given another function, right? And this question says, f is defined on the set of reals and is such that f of x is equal to x squared times e to the minus x, which of the following is correct? So f is decreasing on this interval, f is decreasing on this interval, f is increasing, f is increasing, f is decreasing. So we need to figure out where this function is increasing or where this function is decreasing. Okay, so I'm going to attempt to draw a graph of this function, right? And by sketching the graph, well, I don't need to sketch the graph, but solve an inequality. All right, but sometimes when solving these questions, we can sketch the graph. Okay, so let's go. So f of x equals x squared e to the minus x. This implies that f prime of x is equal to x squared times e to the minus x times negative 1. Let's fix that. To the minus x times negative 1 plus 2x times e to the minus x. Now, f prime of x greater than 0 implies that x squared plus 2x, well, this is a negative x squared, times e to the minus x, right, is greater than 0, which means that x squared plus 2x, well, this is a minus x squared, is greater than 0, since e to the minus x is always greater than 0, right? So what I'm saying here is that under normal circumstances, if we have a product greater than 0, then it means that this term and this term has to be greater than 0, or this term and this term have to be less than 0. So both have to be less than 0 or both have to be greater than 0. In this case, we have one of them being greater than 0, so therefore the other must also be greater than 0. I know some persons didn't get that, but you have to think about it. So now we solve minus x squared plus 2x greater than 0. This means that we have x minus 2, is this x minus 2 times x is less than 0. So what I did there was, guys, I multiplied through by negative 1, right, and factored out my x. So now I look at the quadratic, and where the quadratic is less than 0, right, if I should try and sketch a graph of this function, I would have something looking like this, right? So here, the function is less than 0 when it's in between 0 and, what? 2. So therefore, we have solved when the function is increasing, right? So we can say that f is increasing. F is increasing on which interval? 0 to 2 inclusive, okay? Here it's inclusive. So that means f is decreasing on negative infinity up to 0 union 2 up to infinity. So let's see if any of our answer choices matches that. Nice. So we see that A is our answer. All right. Scrolling. Question number 5. We're given the function f is such that f prime of a is equal to 0 and f prime prime of a is equal to 0. So here the first derivative is 0 and the second derivative is also 0, which of the following must be true. Okay, so it says is necessarily true. Is necessarily means that must be true. Okay, f has a relative maximum at x equal a. I don't think so. F has a relative minimum at x equal a. I don't think so either. C, f has a point of inflection at x equal a. Tricky. This might usually mean that this is the case, because if f has a point of inflection at x equal a, these will be true. But this being true doesn't mean that this is true. So we have to keep scrolling. F has an infinite Taylor series expansion about x equal a. That's not necessarily true either. So I'm gonna go with E for this one. And I'm going with E, and the explanation is simple, guys. I'm gonna say that f of x is equal to the 0 function, right? I know you guys don't know the 0 function, but if we choose f of x to be the 0 function, f prime of x will be equal to 0, and f prime prime at x equal a will also be equal to 0. As a matter of fact, at any x, it will be equal to 0. So f of a and f prime prime at a will also be equal to 0. And the 0 function doesn't have a maximum or a minimum or anything like that at all, or any inflection or any nonsense like that. So here, since we don't know what f is, we only know that f satisfies these conditions, we can't say that it is necessarily true, okay? That it satisfies any of these things, okay? And that's why we have to be very careful, because if I choose the 0 function, the 0 function will satisfy this criterion, but the 0 function does not have a maximum, does not have a minimum, does not have an inflection, and it doesn't have an infinite Taylor series expansion. Okay? So that's something we need to bear in mind. So when we don't know what the function is, we cannot go off saying the function must satisfy this or must satisfy that. Okay? So therefore, E is the perfect answer choice. Scrolling. Question number 6. Question number 6. Let's see if we can do this one. We're given, right? We're given this equivalence relation here. Don't want to use the term equivalence relation, but of course, we have an equation, right? And in our equation, we see that x cubed minus x plus 1 is equal to a plus b times x minus 2 plus c times x minus 2 squared plus d times x minus 2 cubed. The quadruplet a, b, c, d is given by which of these sets? Okay, so here we have to solve. Here we have to solve this equation for the parameters a, b, c, and d. Note, guys, that there are many ways how to actually solve this equation, right? We can actually expand. We can expand this. We can expand this right-hand side and end up with something that correlates to this side, the left-hand side, by equating the coefficients. Okay, so the coefficients on this side would be equal to the coefficients on this side, and then we can solve for a, b, c, and d, of course. All right, so that's just something to bear in mind. But what I'm going to do here, I'm going to recognize that on the left-hand side, well, on the right-hand side, right, we have a Taylor series. Now, guys, even though we look at this Taylor series, we look at this expression and we don't really see a Taylor series because it's not an infinite series, we can still apply the procedure, right, for a Taylor series on this polynomial, because here we have one polynomial and here we have another polynomial, okay? So this expansion here, if we expand it, we should end up with the same polynomial that's on the left-hand side. Therefore, we're looking at the Taylor series application. All right, so let's go. So we're going to say that A is equal to f at 2, okay? Oh my goodness. A is equal to f at 2, right? That's the constant term. And then B is equal to f prime at 2, okay? Then we have C being equal to f prime prime at 2 over 2 factorial, and D, which is equal to f prime prime at 2, well, triple prime, over 3 factorial. All right? And once we apply these, we should end up with the quadruplet. Okay? So we could go the long method, or you could go the short method, but here I'm trying to make this video as short as possible, which is technically impossible, but as short as possible is still, you know what I'm saying. So f of 2 is equal to 2 cubed minus 2 plus 1. Right? If I simplify this, I end up with 8 minus 2 plus 1, which is equal to 7. All right, so that limits our answer choices to these possibilities now. All right, and f prime at 2 is actually 3 times 2 squared minus 1, which is equal to 12 minus 1, which is equal to 11. So now our answer choices are limited even further. So we now have these two possibilities remaining. And now we find our second derivative, which is equal to 6x. Right? So this is 6x, and if we evaluate this at 2, we end up with 6 times 2, which is 12. We have to divide by 2 factorial. Guys, we have to be careful here because we almost thought that the answer was D. Okay? So this is actually equal to 6. So now we are left with only one possibility. Okay? Did I just select the right answer choice? I don't think so. I'm supposed to eliminate this one. Nice. So now we're left with answer choice E, but just to prove that this thing works, we're going to find the third derivative, which is equal to 6 divided by 3 factorial. And if we divide 6 by 3 factorial, it is 6 over 6, which is equal to 1. Oh my goodness. This thing actually works. But how do we know? Like, I know someone is thinking right now, how do I know that this is a Taylor series application? We have to look at this expansion, guys. It's basically an expansion around x equals 2, okay? So x equals 2 is what we're expanding this series around. But this is a polynomial. So if you try to take a polynomial and you transform it into another polynomial, it cannot become an infinite polynomial. It can only be a finite polynomial, as it was already. Okay, remember the Taylor series formula is used to transform non-polynomial functions into infinite polynomial functions. But if we take a polynomial and try to write it as a Taylor series, what we'll end up with is a finite polynomial, same way, just in the Taylor series form. Okay, so that's something that you guys can make a note of. Let's move on to question number 7. Right? So for question number 7, we have a Taylor series for e to the x. Okay, we're given the Taylor series for e to the x, which means we can use it to write down Taylor series for variations of e to the x. All right. So let's make a note of this form. So it's 1 plus x squared divided by 2 plus x cubed divided by 3 factorial plus x to the n divided by n factorial. Okay, all the way up so that we can see the general pattern. Okay, now we are being asked to write down the Taylor series. Well, we are being asked for the coefficient of x cubed in the Taylor series of e to the x squared minus x. I know some persons are tempted to differentiate this function. I know some persons are tempted to differentiate this function, but if we try to differentiate this function 3 times, it's gonna get messy. So what we want to do here is we want to make a note of the Taylor series for e to the x squared and e to the minus x. Why? Simply because e to the x squared minus x is actually the product of e to the x squared and e to the minus x, okay? So if we have both Taylor series, right? If we have a Taylor series expression for e to the x squared and we have a Taylor series for e to the minus x, then when we multiply those two individual Taylor series, right? When we multiply these two Taylor series, we end up with the Taylor series for this function. So that's something that we need to note. So let's write down this one. This one is going to be 1 plus x squared plus x to the 4th power over 2 factorial plus x to the 6th power over 3 factorial plus x to the 8th power over 4 factorial onwards. What about e to the minus x? This one is going to be 1 minus x plus x squared over 2 factorial minus x cubed over 3 factorial plus x to the 4th over 4 factorial onwards. Okay? So in order to write down the coefficient of x cubed, we need to take terms which are less than or equal to x cubed in each. We need to take a truncated version of the Taylor series up to the term including x to the 3rd power if there is a x to the 3rd power, okay? Which means that in order to find this, I'll take 1 plus x squared times 1 minus x plus x squared minus x cubed. And if I take only these terms and multiply them, I should end up with the term in x cubed for this Taylor series, right? I don't need to take x to the 4th power. So here I'll only take these two, put them right here. X to the 4th power cannot give me x to the 3rd power. So that's why I'm stopping at x squared, okay? Here I take this 1 minus x plus x squared minus x to the 3rd power over 3 factorial because this has in a x to the 3rd power. So I'm going to stop here because I want to get an expansion up to x to the 3rd power, okay? So now if I simplify this, if I expand this actually, I now end up with 1 minus x plus x squared minus x cubed over 3 factorial. This is over 2, this is over 3, right? And I am adding that to x squared times the same thing, 1 minus x plus x squared minus x cubed over 3 factorial. Now this gives me 1 minus x plus x squared minus x to the 3rd power over 3 factorial minus, well, plus x squared times, well, minus x cubed plus x to the 4th power minus x to the 5th power over 3 factorial. We now end up with 1 minus x, right, plus 2x squared minus 4 over 3 x cubed. Well, 4 over 3, no, it's not 4 over 3. Almost made a mistake there. 3 factorial is not 3. So 3 factorial is 6, so this is 7 over 6. Right? And how I end up with 7 over 6 is that I am looking at the coefficient of this one and I'm adding the coefficient of negative x cubed. So two negatives, whenever the signs are the same, we add and keep the sign. Now I add x to the 4th power minus x to the 5th power over 3 factorial. So therefore 7 over 6 is our coefficient. Well, negative 7 over 6. So therefore we can.
That is it for this video. Please remember to hit the notification bell, like, share, and subscribe for future post notification.